Hello, in this video I'm going to build on our use and understanding of the tools for defining whether series are convergent or not. And I'm going to talk about the limit comparison test. Very quickly, very easy. I think this video is going to be short. So here's a limitation of the comparison test. Now, actually before we do that, just for practical purposes, because this is really how we're going to be using the limit comparison test, I'm going to tell you one thing and you're going to have to believe me, and I'm going to prove it in the next video, okay? And what I'm going to tell you is that the series of 1 over k squared actually converges. I'll prove it in the next video, but right now just believe me for a second. We know it converges. Let's make that assumption and move on. So if we use the comparison test, it's great for this, right? I can use it for this because I know that this thing is smaller than this thing. And since it's smaller and this thing converges, it follows that this thing here converges. Wonderful. But that's only because this thing is smaller than this thing. What happens if it's actually bigger? I mean, it's bigger, but I know that it's really bigger by just a very little bit, very little. Now, this is when we will use the limit comparison test. Let me explain how it works. So I have two positive series, okay? Let's call it the A series and the B series. Now, when I make the limit as k goes to infinity of one series divided by the other one, and it gives me an actual value, that value is bigger than 0. It can't be 0. It has to be bigger than 0. Okay, so I take two series and I make a limit of 1 divided by the other one and to infinity, and it gives me a value, a limit that's bigger than 0, an actual finite limit. Then, if one series converges, so does the other one. Simple as that. And if one series diverges, then so does the other one. Now, let me use this one. So I have this one here, right? So this one is just a little bit bigger than the other one. So I can't use a comparison test. Let's use the limit comparison test. And let's do it with this one here. So I'm going to make the limit as k goes to infinity of one of the series divided by the other one. And I'm going to end up with this, which is going to give me 1, which is bigger than 0. And now, since this one converges, if one series converges, so does the other one, then by the limit comparison test, I can say that this one converges too. So that's how the limit comparison test works. Just make the limit as k goes to infinity of one series divided by the other one. It's important that you choose well the other one so that it really actually works. But most of the times, it's just going to be easy, straightforward. You look at this one, you know, I mean, it's so similar to this one. If only I didn't have this -1. Well, don't worry about it. Just use the limit comparison test. So that's it. Nothing else to it. Let's just make a quick example and move on. Let's make two examples, actually. Okay, so first one here. Let's actually start with this one. I take this one, I make the limit as goes to infinity, and I'm going to compare it with 1 over k squared, just like before. And I'm going to end up with this limit. And again, this limit is going to give me 1, which is bigger than 0. And since we know that this series here converges, then we know this one here converges. Pretty much the same thing. This is the other one. Well, this one here I know is very similar to this one here. I can't use the comparison test because it's a little bit smaller. And this one actually diverges, so I can't use that one. But I'm just going to do the limit comparison test in that case. And I do it this way, and I end up with this thing here, which of course might be a complicated limit, but you just have to multiply on the top and the bottom by this thing here, and you're going to end up with a 1 here and a 1 here because it's going to cancel out, right? So you're going to actually end up with this. Trust me, do the calculations if you wish. Now this limit gives you 1. Great. Now I know that this series here diverges because the ratio is bigger than 1. So if this one diverges, since the limit gives me 1, by the limit comparison test, this one here also diverges. And that's it. That's the limit comparison test works. Thank you very much for watching. Goodbye.